the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. And joining me to answer this question is Jacob Becker, System Solution Architect at System Integrator Tritech Automation. There seems to be, three big differences when you look at comparing soft starters and VFDs. The first of which, of course, is cost, with soft starters being the cheaper option. Then there's the ability to control motor speed, which VFDs offer, but soft starters lack. And then there's performance parameters and tuning capabilities, both of which have more options on VFDs than soft starters. But beyond those main factors, are there other key differences that users should be aware of when deciding between the two?
Sure, absolutely. The first would be complexity. A VFD is a considerably more complex piece of equipment than what a soft starter is. It has a lot more active components, IGBTs, capacitors, rectifiers, things of that nature. Since it has more active components, like you mentioned, there is additional cost. There also is a size difference. For a like motor size, a VFD is typically going to be fairly bigger than a soft starter. We all know that plant floor space is at a premium. So if you don't need a VFD, a soft starter might be a great way to save some space and additionally some cost. The next difference is heat. Like I mentioned, there's a lot more active components in a VFD. A VFD of equal size to a soft starter will put out considerably more heat than a soft starter will, because the components, as we'll talk about later, are always active on a VFD. So a lot of the components that we need to worry about are around the installation of VFDs. So the size, the heat, additionally is cabling. So with a VFD, since we chop up that waveform and we create that simulated square wave out on the line, you can get a reflected wave back on the cabling. So oftentimes a special cabling and then a line reactor is also recommended for long runs to prevent harmonics from being passed back onto the power source. So if you have a lot of VFDs with long runs, you run the risk of getting harmonic distortion on your power source, and that can affect other equipment in the plant, especially sensitive equipment like instrumentation or PLCs.
And I imagine, would that also have an impact on the type of enclosure that you
It
choose
adds
based on that as
it
well?
it absolutely would. It's going to make your enclosure a lot bigger, and that's going to come back to space. And yeah, VFDs take up quite a bit more space.
Okay, good point. Thank you. So, with more manufacturers, looking to make their operations, more sustainable and reduce energy costs, I would think that overall efficiency would be an important consideration when making the decision between a soft starter or a VFD. I mean, on the one hand, you have the ability with a VFD to control motor speeds, which can have a significant impact on efficiencies and cost. But soft starters also help reduce motor energy use. And looking at the overall operation of the two devices, soft starters often edge out VFDs in terms of operating efficiency, though just by a couple of percentage points. So, considering all these issues, which one is likely to be the more efficient energy choice overall?
Sure, that's a great question. And like a lot of questions in engineering, it's kind of it depends. It all comes down to an application standpoint. If you have a motor that you know you're going to start up and you want to start it up in a controlled fashion, but it is going to run at a fixed speed all the time, the soft start is the clear answer. Simply due to the fact that a lot of soft starters have bypass contactors either inside them or they will be added externally. So that means once the motor is up to speed, we will energize the bypass contactor, and then the soft starter components will actually shut down and not use any power. So there's no efficiency loss there. The only time they're active is during the startup and potentially, depending on application, the shutdown of that motor. Now, a VFD would be more efficient in an instance where you might be able to start up a motor and run it at full speed for a period of time. But during a low load application, you still need to run it, but you can reduce the speed of that motor, say for a fan or a pump during a low load application, but you still need those devices to run. You could slow them down, and that would be a more energy efficient standpoint. But if you need to start it up and run it at full speed at 60 hertz all the time, the VFD will be constantly active. The IGBTs, the filters, everything is active, and that draws some power. and will make them slightly less efficient. Though they're both devices are extremely efficient as far as equipment goes.